In this video, we will generate a bitstream file in Vivado using the non-project mode. We will accomplish this by creating a script that executes each step of the development flow. The first step in our non-project mode script is to set the device for which we want to generate a bitstream. We do this by using the setPart command. The next step is to read the input files. Here we'll use 3 commands, one for each file type: RTL files, IP files, and constraints files. For the RTL files, we'll use the read verilog command. There's an equivalent read VHDL command for VHDL sources. For the IP files, we'll use the read IP command. For the constraints files, we'll use the read XDC command. IP cores are usually described in a vendor-specific format that cannot be directly simulated or synthesized. Therefore, we must synthesize the IP cores using the synthip command. Vivado will find the synthesis results whenever the IP core is instantiated in our RTL sources. We are now ready to synthesize our design. To run synthesis, we use the synth design command, and we pass the name of the top-level unit in our design. After the synth design command runs, we will have a synthesized design in memory, ready to be placed and routed. However, since we are in non-project mode, we won't automatically receive any reports about the synthesized design, and we will not be able to access the design itself after closing the Vivado session. The write checkpoint command allows us to store the current state of the design in a single file. We can then load the design checkpoint in the Vivado GUI or the command line and run any analysis and report tools that we'd like. We can also run those reports immediately after running synthesis and writing the design checkpoint, as shown here. We can now run placement by executing the place design command. We don't need to indicate a target for placement. Vivado will use the synthesized design from the previous step. Though not necessary, running design optimization before placement and physical optimization after placement usually helps reduce resource utilization and makes it easier to achieve timing closure. We are now ready to perform routing by executing the route design command. As we mentioned earlier, we don't need to indicate a target for the routing. Vivado will use the place design from the previous step. The same strategy for writing design checkpoints and generating reports applies to the routed design as well. After our design has been routed successfully, we are finally ready to write the bitstream file that can be programmed onto our FPGA. To do this, we use the write bitstream command. We must pass the name of the new bitstream file as an argument to the write bitstream command. The force option automatically overwrites an existing bitstream file with the newly created one, a common scenario where we are making changes to our design. We can run the entire script at once by opening a terminal in the project folder where we have stored our non-project mode script as a tickle file and running Vivado in batch mode. We can see that the bitstream file has been created along with the design checkpoints and reports for each stage of the process. We can examine the design checkpoints by launching Vivado and selecting File, Checkpoint, and Open. From there, we can choose one of the design checkpoint files stored in the project folder. Since we are in non-project mode, the Vivado GUI does not display the Flow Navigator pane on the left-hand side, and we cannot access the design sources.